Inverse sine function. If we look at y equals inverse sine of x, okay, or sometimes it's written as arcsin, what that means is sine of what equals x, okay? Sine of y is going to equal x. So inverse sine is kind of undoing the sine function, I suppose. All right, now you see this and you see this, that range of from negative pi over 2 to positive pi over 2 is going to be really important. In fact, the domain and range are going to be really important in this lesson. And each of the 6 trig functions or inverse trig functions are going to be slightly different. So we're going to have to really pay attention to domain and range. For inverse sine, the domain is from negative 1 to positive 1. And its range is from negative pi over 2 to positive pi over 2. Now, occasionally we'll be in degrees, so that would be like from negative 90 degrees to positive 90 degrees. But in general, most of the time we're going to be in radians, so we would say from negative pi over 2 to positive pi over 2. Okay? That's going to be really important that you remember those 2 things. So, I don't know if you want to put a star by those, or circle those, or whatever. Those are going to be really important. X-intercept of the graph is at 0, y-intercept of the graph is at 0. And then this graph is symmetric at the origin, which makes it an odd function. We've talked about odd functions and even functions in the past, but we're talking about inverse sine. Strangely enough, this is the graph of inverse sine. We won't really have to do anything with the graph, but what we can notice is the x values. The domain, that's between negative 1 and 1, and then the y values, or the range, is between negative pi over 2 and so we can see that domain and range inside that graph. But we don't really have to graph anything. You're going to need to be able to understand that domain is negative 1 to 1 and range is from negative pi over 2 to plus pi. So when we do these examples, the examples are really pretty quick. Okay? They're really pretty quick. But it is important to keep in mind the domain and the range. So we just talked about that. The domain for inverse sine is from negative 1 to 1, and the range for inverse sine is from negative pi over 2 to positive pi over 2. Okay? Now, a couple things to remember. For domain, that I don't think a very good definition for domain is the x numbers. I know that's what everybody says. When I say, what's domain, you'll say the x numbers. And that's kind of true, but that's a very limited definition. I think a better way of thinking about it as the inputs. Okay? Domain is talking about the input values, or what you're allowed to plug in. And the range is the output, or what will come out. Okay, what your answer would be, I suppose. Okay? So domain is input, range is output. Also with the range, negative pi over 2 to positive pi over 2. We all should know that pi over 2 is up here, like 90 degrees. Okay? So negative pi over 2 would be down here. That's like negative 90 degrees. And so when it says that the range is from negative pi over 2 to positive pi over 2, it's talking about from here to here, basically. Or, in other words, they're talking about quadrants 1 and 4. So your takeaway should be this, okay? A positive value is going to be in quadrant 1, and a negative value is going to be in quadrant 4. Okay? We're going to have to think about what and where. And so what is going to come from the chart usually. Where, if it's positive, it's in quadrant 1, and if it's negative, it's in quadrant 4. Okay. So when we look at a problem like part A, example A, it's going to look really simple because we do arcsin or inverse sine, and we can look at the chart, and we've done this before. We do inverse sine, and so we find the sine and we find the 1/2, and we use the chart backwards. And if we use the chart backwards, we're going to arrive at an angle of pi over 6. Okay? Pi over 6. That feels like we've done that before. Okay? But that's the what. All right? That's the what. The where is kind of subtle. But when you're looking at this input value of 1/2 and seeing that that's a positive number, then you would come over here and say, well, positive numbers are going to be located in the inverse quadrants. And so I'm just talking about pi over 6 in the first quadrant. And so pi over 6 in the first quadrant just is what it is. And so this answer is pi over 6. I realize it feels like I talked over this problem for way too much for such an easy problem. You use the chart backwards, you get pi over 6. That's it. Some of these problems are a lot more complicated than that. Okay? When we look at inverse sine of -1, inverse sine of -1, okay, just treat it like a 1 first of all, but if I look at my chart, an inverse sine and a 1, that's leading you to an angle of pi over 2, right? Pi over 2. That is the what. But then you come over here and say, well, negative, okay, negative means that my angle is in the fourth quadrant. And so what you're going to want to do is you're going to want to put a pi over 2 here, okay? And it's very tempting to do what we've done in the past chapters and go all the way around here. Did I say pi over 2? I guess that's not where pi over 2 is. I'm sorry. It's tempting to say negative pi over 2 is right here. So it's tempting for people to go all the way around and to call that 3 pi over 2. Okay? But 3 pi over 2 is not in the range. Okay? 3 pi over 2 is not in the range. The acceptable interval, or the acceptable range, is from negative pi over 2 to positive pi over 2. And so I think a better way of looking at this one is when you have this range, ask yourself the question, am I even allowed to have a negative answer? Am I allowed to have a negative answer? If you're allowed to have a negative answer, then this is just going to be negative pi over 2. That won't always be the case because all of the trig functions won't have negative answers. It's impossible. Okay? That one is. So the what, I get the pi over 2 from the chart, and the where, I know this is in the fourth quadrant. That negative right there tells me that we're going to be in the fourth quadrant. And I know I can have a negative answer in the fourth quadrant. Negative pi over 2. Okay. Now, part C, inverse sine of -2. Okay? And that's not on the chart, I suppose, so that's your first problem you're looking at. But also notice your domain. Remember how the domain was from -1 to 1? That's talking about input values. That's talking about what I am even allowed to plug in. I can plug in any number I want to as long as it's in between -1 and 1. Those are the input values. What that means is I'm not even allowed to plug in -2. I can't. It's not going to work. Okay? It's not going to work, and so this is